Welcome back to Cloud Computing and Big Data. Today we have our short lecture 15, and we change a little bit this perspective now. Basically, we're talking about the idea that OpenStack enables us to create our own clouds. So we don't use the hyperscalers from AWS or MS Azure or Google Cloud, but rather are tasked, maybe by the head of IT, to create an own cloud, basically somewhere within your own organization. And to not start there from scratch, OpenStack provides us with a lot of components, really, which you can say in one respect, acts essentially like a cloud operating system. So very interesting material. Again, a short lecture today. For the full lecture, please go to the last year's lecture. But before we start with the material of short lecture 15, let us review what Marcel has taught you a little bit about the interesting topic of hyperparameter optimization and basically open machine learning, AutoML, and so on. So he started a little bit by making you aware again what we learned already at the beginning of the course, that some of the parameters in these machine learning models are not parameters that you learn. So they are not the W's, if you remember with the perceptron learning models, where we summed basically the signals up linearly using weights and then trained these weights until we came to a good conclusion, or let's say at least to a good accuracy. And we did this over and over again, essentially then continuing with artificial neural networks, where also Andy has shown you actually lots of parameters. But what basically Marcel then talked to you is there's another set of parameters we call hyperparameters. And they're, in this sense, hyperparameters because they are steering the learning process and maybe also influencing the capacity of the model. For instance, if you think the number of neurons in each layer of an artificial neural network. So these are all parameters that you pick as a human and are not really picked, let's say, by the learning process or learning algorithm. Hence, the interesting benefit that you always have when you use HPC, that you see here a little bit, is you can do faster training. Yes, we learned this throughout the course. Thank you. We know that now, but thank you very much. But the second benefit is really that we have a systematic hyperparameter optimization that we can use with high performance computing and in clouds, which helps us significantly. For instance, SageMaker and some tools in the hyperscalers have these services available to really tune machine learning models better and make them better in performance. That's what better really means. It's a lower error rate, or if you want, an increased accuracy. And because we have more and more GPUs available, we can do this very nicely. He showed you a little bit about RightTune, how to do this different, let's say, trials with different parameter runs. And I think this interesting element here is a good example of one of these hyperparameters called the learning rate, which steers essentially then the progress of your learning over the error surface and how fast you are. If you remember, we talked a little bit about this when we had the optimization recap in one of my lectures. But you see here just a small difference, really tiny, really, in the learning rate can make a huge difference in accuracy. Take, for instance, right, the green one here of an accuracy, which is perhaps here 0.0004. And this is what you pick as a human. Well, it's also not really intuitive, is it? But then suddenly you just say, okay, I picked 0.002, and I'm landing in the top accuracy here, 90%. So this is real. So this is indeed something which we humans just set in the Python scripts normally. And in order to pick this more systematically, there are these tools called RayTune, where you can play not only with the learning rate, there are many other hyperparameters, even the optimizers, depends on what you want to optimize for. You can have a couple of hyperparameters really in the game where you can optimize your modeling. And with this, you really get then better models. This reaches a little bit also in the idea of AutoML technique, right? So this is basically an interesting method to do ensemble learning, for instance, here with AutoGluon. For instance, when you go away from, let's say, one particular learning model that knows it all. Ensemble learning means you combine perhaps regression with some support vector machine and maybe a foundation models. And we talked also about this foundation model idea with Kronos. there where you basically have a pre-trained model that has already seen a lot of data, and you use it for downstream tasks, retrain it, or for the given problem at hand. And this is really nicely supported in all these clouds. You see it with Ray here. Essentially, they are all in the different hyperscalers or big cloud vendors, but also, of course, can be nicely put, in Kubernetes or kubelets and then shipped around and are really portable. So in the end, this is basically just a tool. It's not a new AI model. It rather helps existing AI models you want to do to really do this. While AutoGluon then provides you with a new model, essentially, where you use ensemble learning, for instance, based on Chronos, and have another set of regression and support vector machines. These are different things, but of course they are related in the sense that how to pick then automatically these parameters or which learning model. There's a, let's say, not a really very complete difference of saying, well, when I change the number of neurons, right, is that already a new AI model? Or is it something which is AutoML if it, make it automatically with AutoGluon? So hence, this is a little bit where you see here also a very nice short graphic, very interesting, an area where you also often as a human just say, well, let's put, the number of neurons 512. And then, this was not good enough. Maybe we take much more parameters, 1,000. Okay, 80 score, even less, not good. Then you would say maybe and continue with 2,000, 3,000 networks, and we'll see. You maybe actually do something which is not so intuitive, but rather say I increase the number of layers and then do less neurons, where you suddenly end up with a quite good performance, 92. But you picking this as a hyperparameter, let's say, manager, and systematically over the whole search space, right? We're talking here about 3 hyperparameters, number of layers, 3, okay, maybe 5. Number of neurons, 512 or 256, depending on how many layers. And then I have a learning rate. Should I put 0.1 or maybe 0.01? You get the story. So there are more of these combined, which makes it very hard for humans, of course, to get to the right ones. And hence, there's an optimization that you can do by using then this RayTune, or if you go the full force, make AutoML techniques, then basically you have automatically the chance of maybe, that these parameters are picked for you from this AutoGluon and AutoML techniques. I leave it as there. Also think about that this was a short, basically lecture in previous years. We had also longer lectures on this without the industry project taking so much time, but please feel free to go always in the YouTube channel to the old lectures and then the review, the full lecture if you want for more information. The same goes today as we basically now conclude the course almost, let's say, at least formally with this lecture. We have another epilogue coming where I talk a little bit about jobs and from another perspective of the course, what you have learned and what hopefully stays in your mind for a long time. So today we will reveal this OpenStack cloud operating system, which is important to have at the end of the course, because essentially you can now flip the view, as we said in the beginning, of saying now you are in the role of creating a cloud, right? Of course, we can here just cover just the basics for understanding all the wide variety of OpenStack components. You need really, again, a complete course, either in the university or let's say a training from Monday morning to Friday afternoon. What is actually in industry common? So there are actually trainings on this where you can take them and in the end you have a certification even. But this is something what we can't provide here is just one university lecture. So I give you an overview as usual, and then you have to, let's say, keep that hopefully in your mind. And when your boss comes in the door in some IT company and says, might be not even an IT company, might be another company that just needs computing, right? Pharmaceutical or industry, whatever. So then they come in your door and says, well, we do some Amazon, please, but we also want to have our private cloud in-house. We have very sensitive patient data. We want to try out a new medicine idea. This is something which is really sensitive. Don't put that into AWS. So then you are starting of thinking, oh, there are a lot of components I need, right? And talking then about scalability, that's what we also will review today. So horizontal scalability with clouds, all the benefits we learned, right? Up, down, and demand, how I provision this in the multi-tenant way, right? Virtualization to the rescue. All of these different components we had in the whole course, infrastructure as a service ideas, platform as a service ideas, software as a service ideas for the pharmaceutical engineers or for the researchers should be pretty simple to use on the software as a service level. Then you have the, let's say, private hybrid cloud idea, right? So how do you have the interfaces right for S3 maybe to have some public data pulled into the private cloud, and et cetera, et cetera. So with this, we fulfill also a lot of promises we always had. And it was important to first go through the whole material so that you can now nicely always revisit actually what we did and make the basically combined idea of thinking, how would it look like if I have to do it as an OpenStack engineer? So let's go with some things we already know. Let's revisit a little bit the Google Cloud example where we talked a lot about Kubernetes. We talked about the benefits of using containerization, if you remember, right? Across basically the whole idea of having these applications, because you don't carry around the hypervisor and so on. So you would do rather maybe lots of containerized applications. But for some ideas, virtualization in the old traditional way here could be still useful, right? And we explored a few in lecture 4. But when you then come to the idea, what we discussed basically in the couple of last lectures, especially platform as a service, Kubernetes, you have the Google Cloud Platform. Yes, you can use other cloud platforms. And here's the idea now that you really think about what happens if your data center should be there alongside. And the idea is, of course, using this then maybe with Kubernetes, with kubelets and so on, so that you're actually able to even shift this. When you have similar algorithms, let's say on public data, you try out on the Google Cloud Platform, but for sensitive patient data, which is private, you don't put in the public clouds. You can use the same algorithms and the same idea you have tested basically in the public data now on your private data. It's just one use case out of the medical domain, but there are many of these use cases. Car manufacturers the same way. Should also mention that actually OpenStack is not just one open source tool. It's actually an open infrastructure foundation tool, which is sort of a top level project supported really. So that means if you pick this open source tool as OpenStack within your, let's say, data center to create your own cloud, the chances are that this open tool will not disappear very quickly, right? So this is really stable. This is sort of the trust that we put into this. And luckily, as an open infrastructure foundation project, you can be very certain that this will not disappear, which is of course important because it can take quite some time if you create, an OpenStack infrastructure in your organization. So let us review a little bit when we come across all these different challenges that you need to address, of course, now when you are in charge to create this. So, and we want to do this, of course, also with scalability, right? You remember all the scalability metrics that we will also review a bit. We want to have that included. So hence, we want to pick these components and, we look in the huge set of OpenStack. We'll provide a couple of examples. And of course, the basis that we discovered in virtualization is still the same, right? You have this virtualization that helps you from basically enables us then here to abstract from the physical hardware. So the same concepts still apply, but what happens with all of these components here to create a virtualized infrastructure, this infrastructure services we discussed already, this is something what we want. And with this also enable this, what you see here quite nicely, horizontal scaling, right? Going more and more if you need more or less computing and so on. And it should be also all supported, especially the increase in users, or maybe, sometimes also decrease in users. But your, infrastructure should be still, let's say, working quite good with the components at hand. So how does it look like? And you quite nicely see here a little bit, again, in a review, what we had a bit discovered in the last time, that you have this, bare metal idea that, you can do, which is essentially almost infrastructure as a service if you want, or you have virtual machines that you can support. We discussed about this, and of course the containers that we discussed as well. So, and there's components for all of that, how you basically create this. And of course use Kubernetes and with it, what we already discussed, or you basically create your own, let's say UI, for instance, on top of it. And this is something which all gives you basically now OpenStack, and you can manage, of course, your direct hardware. However, of course, when you have a real view, like here you see OpenStack shared services in compute, network, and storage, don't forget that you have your hardware still, right? Obviously, we need always this physical hardware. Otherwise, you can't do anything. So this is, of course, there. It just helps you to manage this infrastructure and to build it as you like, because you don't maybe need everything. Examples could include that basically you just need compute and networking, but you always use the S3 storage because you always work on public data. So, and you don't want to have your own system in a very flexible storage scale created. You maybe just don't need that, and take the S3 interface, which is an external in another cloud. There are all these mechanisms of combining then what you want to do. But it's really an active open source project, and this also gives us the good view that many people work on it, which is good for the sustainability, for the functionality. It also basically captures then so many real world applications. And this is mostly done with so-called sample configurations, because many people work with OpenStack and contribute to OpenStack. Of course, people in return also use OpenStack a lot because of that. So you have seen that OpenStack is now used so broadly. And with this come, let's say, this OpenStack marketplace sample configurations where you don't have to start from scratch. And a good example that we know is the MapReduce, right? I will conclude today. When you think about Hadoop, right? In one of the lectures with data analytics, we had this, that, we have this worker paradigm or divide and conquer, where you increase the number of workers, scale up and down, and so on. So this is just beautifully provided already as some sample configuration with this scheme of divide and conquer. So you can basically then tune this for your own needs in your own organization. So you also don't have to, pick the components you need. This is all already set up. And we go through a couple of those today. So hence, I encourage you to go a little bit of, into the idea of the marketplace and see what it can do. And for OpenStack, really, it's important to know that always the resource pools are important that you have, which are the three here: compute, networking, storage in a certain abstract sense. But of course, if you dive into the different services landscape of OpenStack, you will see that compute is not only compute. There's lots of key functionality. Remember EC2, right, versus AMI, the Amazon machine interfaces, already virtualization in the game. The other is just basically EC2. So just essentially computing, but it's scalable. And the AMI had already some tools inside. So for all of that, this is of course important to have the benefits of the cloud, which is horizontal scalability that I already discussed, and also the other scalability metrics we basically have revealed in one of the earlier slides. So we go not too telly in details into it, but to remember it was also software, the technology, remember Apache Hadoop versions, they change very often with all the different stack around it. So it's quite a challenge to do this. Now, when you think about some application examples, just impact in business on the left-hand side, some of these are very well known, like Blizzard. I think this is probably what everybody of you know, or the majority is really one of the best, performing, I think, game builders. And, this is, they have lots of success also doing this in the cloud. And there's, let's say, many that also use some of the OpenStack elements for it. Then Walmart, basically in US, is quite well known, using also a lot from OpenStack. Then Open Metal is another one, a very more specific one. So you can, of course, go to the website and then you see how many essentially, users are using it. And the million of cores, which you see here on the top as an indicator, gives you also an idea, is that, something which is really stable for you to use. Hence, we, as an example, I'm also in the Jülich Supercomputing Center, and that's why also quite nice to be here now in the supercomputing conference here in St. Louis, because we reached exascale finally with our Jupyter system. So very happy. I'm still sorry that I can't not be physically with you in the course right now, but I'm definitively with you in the spirit of concluding the course nicely now today, and also with Ingolbe with the industry project. We are soon going to the end, but here, coming back to the cloud, you see that the Jülich Supercomputing Center has basically done the same. It created its own OpenStack environment, what essentially is called the JC Cloud, which is based on OpenStack. So it has, of course, interesting interfaces to go to the HPC machines. It's very close to it. with the data file systems and so on. But here we reuse different components from OpenStack. And of course, this took some time to get, let's say, really up and running. But also this enables us to provide, the flexible services you have seen also in the, let's say, previous lectures every now and then when we talked about Jupyter and all of that, which is then also, an access methods to the JC cloud. So lots of services are around this. And this should just show you that, if you're in business or in academics, OpenStack can be still very interesting for you. So looking a bit back to the data center metrics, and we have discussed this already, so I don't want to go completely after it, just to remind you that if you want to do it in your own organizations, you have to fulfill this, right? So in many cases, maybe not in all the cases that you see here, but the size, add, remove processors to it, add more and more storage to it, whatever you think about that your physical hardware is really, increased or decreased. So the size is really something you have to take components to it. If you develop that from scratch, then, this is really a lot of work. And you can do this, but it doesn't make sense because OpenStack can work with the size scalability very nicely. And then the software scalability we discussed as well. You have to deal with lots of different libraries. You have to they have to play together in all the different programming environments and the tools from machine learning. The CUDA libraries must match the GPUs that you have in your physical infrastructure. If you want to do deep learning, this is not the only thing. Then there's also, cuDNN and lower level networking drivers you have to combine with it. And then maybe even some other engineering mathematical libraries you want to use also then PyTorch with CUDA, with GPUs. Hence, software scalability means it needs to scale, of course, and deploy it across your cluster to work. But then also there, the different versions have to really also maintained, worked on, and so on. So all of these metrics, is something where OpenStack can help a lot. Of course, there's still some work to do, right? I want to not do, and say, it just can press install and then this OpenStack, everything is fine. There's still lots of configurations with these components. But instead of rewriting all of these components to fulfill the scalability metrics here and address them, this is quite a challenge. And it makes sense to use OpenStack for it. Also, when you think about the application scalability, again, we said about the example maybe here with MapReduce, we come always again and again to it. You want to scale that maybe, also the data set is too big suddenly. And then suddenly we see, okay, we need much more workers. So we scale up, we see application with the computing and, in this divide and conquer, or if you remember, it was map, sort, shuffle, reduce. Then essentially you add more workers dynamically, right? Depending on how much data this time you have to process with the MapReduce technology. Hence, this is also an important factor. And finally, technology scalability in itself. You can imagine the new generation GPUs, CPUs coming basically coming in the infrastructure. Often it is a mix maybe in your own infrastructure, let's say from A100s, and now you get another funding within your organization and another idea, maybe another grant, whatever it is, but investor money that says, okay, now we can basically have a couple of Blackwells, maybe B300s, very new material from GPUs, which are excellent for AI, for instance. They're maybe not good for other things, but B300s would be very nice to have for this project. So let's put it into your infrastructure. And then you have a mix of different technologies, to work with. And this is also something where you then as a developer have to branch, have different technology parts for this particular technology, for that particular technology. So it adds to the complexity again, and is really a challenge in order to scale with this technology. In particular, I name here the GPUs because they're very quick, they're very new, and come along very fast, right? While A100s Ampere was just very good a couple of years ago, now that was then suddenly Grace Hopper. And then now we're talking basically about Blackwell all the time. So this is all generations of, NVIDIA GPUs. Of course, I should say it's just NVIDIA, also the Instinct cards, for instance, from AMD are also developing and so on and have different versions. And this also all is something which OpenStack can work with. So let's have a look on the on the overall view, particularly, of course, also compute components. We will look in a little bit now and review them. Again, we will not go in all the different details, but that's why we have to think a little bit here now on, the time also in this, let's say, little lecture for such a big topic. But you see a very nice overview. The core components, if you want, what we already said is compute. And here you see it now nicely broken down in different specific functionality. So compute, what means that? Virtual machines or even containers already. We have this different type of storage. If you remember, we talked about this with the S3 and also with the elastic block storage, object storage, block storage, file storage. Then networking, this is something I leave a little bit out here. But of course, this comes very much quicker than also when you think about outside, inside protection of your clouds is also a very important topic, but not the focus of this course. And there are lots of different components. Another one which is important is the identity management. You can, of course, can think about that many of this cloud, users are maybe in different divisions in your company, have different rights to do certain things. So you need a proper identity. And then Glance, for instance, is there as an example that you also learned that, we have this, images that we have prepared for visualization. So then let's use this and have essentially an image storage for that. So there's lots of that, let's say, which are the OpenStack core components. And a lot of them is also to look at the lifetime management of it. What you see here a little bit, but also here to see a little bit what means when you have to scale up, scale down, orchestrate different services together. And of course, when you think you're running it, let's say as the IT department, you also want to have lots of tools, right? So monitoring, is it really working? Do we have good performance? What about the number of users, et cetera, et cetera? Do you have a billing strategy, right? Maybe within the company, not really real money, but at least core hours or something where you say you value a little bit what the people are used. So to see the usage and to put it in perspective. So there are lots of these tools, and we picked now a couple of these to remind you what we learned earlier. For instance, here on the infrastructure as a service level, very early in the course, we talked about the EC2 interface from Amazon, right? And I don't talk about this again, you know by now how it works. So, but the point is what we have to do when we now want to have something similar, right? Because now you can imagine that we need several different services actually to create something like this, right? When we think an EC2 with a virtualization, you see here an example how that could work, having the different core services where you have, in the end, something you want to have is a VM. But you see there are lots of different services around it which need to be there. And, you need a computing service that is then provisioning the VM. And you need let's say, some storage services where, basically this Glance is the images, right, that we have, and it stores images in a Swift component, which then gives you the opportunity to have, your image stored, or provides the image, of course, to run then the VM in this particular use case in this certain moment when you want to, let's say, provision it via the Nova service. So in other words, put really computing to it. And then, have the neutron, this is basically the network connection. And for orchestration of all of these different services, you need, for instance, here an optional service, which is quite helpful, called Heat, giving you then also interesting triggers, monitoring possibilities combined. Obviously, you need two other things, which is, of course, then the identity management we discussed, provide the authentication, who can access the virtualization management. You remember in EC2, we talked also about the SSH, right? We have to do, before we do any EC2 instance or image, we always have to upload first an SSH key. It's very low level, infrastructure as a service, but that's how it works. And similar here, we need first some way of authenticate ourselves that we can actually use something of this. And then you want to have a UI, don't forget this. So this is plain, let's say, computer science stuff in a very provocative way, right, to say. So this is lots of components working somehow together configured. But, when you now want to have something like the EC2 interface that we have seen in Amazon, you need a UI that basically people can understand. Let's say, go through the Glance here and select the image you need. Is it the deep learning image you need, or with lots of deep learning installed packages, or Is it maybe also something else, maybe more CPU-oriented physics libraries, number cruncher libraries we need in this particular example? So using these services really together, you see, brings the benefit of OpenStack. And when we here now look at another example for the Nova virtual machines, for instance, you see here nicely how this then again works together. It's similar like you have seen before with the glance, basically providing you then the image and so on, and you have some, idea of using then this compute. And here you see then the nice scaling of it, right? You see hypervisor that then in the end has the VM, instance it on your all computing infrastructure, while the Neutron and so on provides a network connectivity, Keystone, the API for having your authentication done and the identity management. And then you have really a sort of small way of operating the cluster, can have the scheduler alongside it. And it has lots of building blocks really that you can use if you really dive into one of these components, which is this Nova compute service. Right? You see, it gets more and more complex the more you go from the abstract level, as we said, just compute, into a very specific service called Nova. And how it then, of course, can work in different contexts. Here is something where we want to do. For instance, again, thinking about MapReduce, this could be one setup of using this for MapReduce, or any other idea how you use normally EC2 in Amazon. And this is used in different use cases. So basically here you have one, we had also earlier already a bit discussed, where you now basically have the idea from VW, a kind of car manufacturer, which then combines, basically the hybrid cloud with a private cloud, but also using Amazon EC2 and Google maybe, but, have also their own cloud inside, right? That is basically the idea of creating then this hybrid cloud. And they also use OpenStack for that in this particular example. So you see, it's basically used across different industries. And again, from a car manufacturer point of view, you know that some of the ideas of new cars or new functionalities in cars are very sensitive to these kind of manufacturers. So they want to keep these rather in-house and, have other things that they can have in the public. That's not a problem. I mean, public cloud doesn't mean that, of course, everybody can access it, but it still leaves, let's say, the boundary of the organization, and it can be tricky with some sensitive data, like we also discussed in hospitals. Now, going one step further, we basically said now, okay, EC2 is what we can do. That was pretty much infrastructure as a service. And then we discussed a lot in our previous lectures around the benefits of Docker and containerizations. We have discussed already about Kubernetes. And of course, there's the other computing service called Sun, which is actually in OpenStack exactly for this, which is not surprising us, is also helping us a lot with images, but then having also, basically the idea of having a different service to it with a Docker and, this container service, using then these directly, in parallel, this component. So again, a good example, if you go into details, it really provides you, let's say, a lot of different ways how you can deploy then these containers, right? Remember, we call them lightweight because there's not anymore this operating system in it. And essentially, you can manage now these components together in this infrastructure and basically combine it if you want, even then with Nova, right? And having then the virtual machine with compute if you want. But this is something where essentially also the Sun compute environment helps you a lot in this idea. Again, for this, we'd probably a whole day to go all through, because you also would be interested now how this works together with Kubernetes would be a next example. And this is something also what, is of course something that you can combine. But let us review also a little bit of storage needs. So object as a storage as a service, so S3 we discussed a lot of times, so I can also hop here automatically over it. We have discussed the EBS, elastic block storage, also in Amazon, what we have to do there, and what the benefit is there, that you just think in blocks and you can do up and down and scale up your infrastructure again, and can be, having benefits from replication and so on. So this is, of course, all something, plus then the file idea that we had in Amazon, you see, elastic file system. These are all different usage scenarios, how you actually work with data. So hence, this could be something where your boss wants to have this in your own cloud at home, right, in your own organization. So how you do this, you know the answer. You look what's OpenStack can provide us in the similar space, and you will see more or less a direct mapping of what we just have seen. So there's a Swift service for object storage, there's a Cinder service for block storage, and Malida service for files. So of course, it's not exactly the same that you have in Amazon. And also you have to combine it with a nice UI we discussed, right? So Horizon, Web UI, whatever on top. But you can do have similar functionality basically provided with you in-house of using this. And by this also benefit essentially then again from the scale out function of storage dynamically. The fault tolerance was for us a big topic also in the MapReduce lecture where we talked about what happens if, maybe one storage is actually failing. So do we have a replication somewhere from the same data? So this could be quickly also be very important for companies that rely on this data for their business. Hence, it's an important factor. And what you otherwise would have to implement is all given here already in all these components, right? So you basically can configure them to your need and use them. And with this can basically mimic almost like you have Amazon services. But of course, this would be cost free for you because it's inside your own basically organization. And then we discussed a lot about the big data analytics already. Also here is a very good example of how you can use an existing part from OpenStack already. You see here the master and worker paradigm, which we discussed with this name node that knows a little bit, and the resource manager is scheduling all the tasks, and the name node knows about the different data nodes and where you basically have what data and so on in order to schedule this map task and the reduce task close to the data. So this would be one usage scenario where really basically Spark, the MLlib, you can nicely combine this with OpenStack. And by doing this, have all the components you need in order to do maybe frequent pattern mining. You have seen this with Shadi, with the FP growth algorithm, for instance, that was important. I don't repeat this here because basically that was provided by Shadi already. But if you now want to implement it, you can nicely see that this mapping is almost again, a one-to-one mapping using, of course, a lot of compute services. Hence, we use a Nova service from OpenStack. That was what a bit was mimicking, for instance, EC2. And then we had the Nova and Cinder, basically. So here, the name node needs, of course, a little bit of storage aligned, right? To know a little bit about the data blocks, not the data blocks themselves, but where the metadata basically gives us the information, then where are the data nodes that we need. So this needs, of course, and again, Cinder storage. Then the node manager is again pretty much related to computing, so managing the nodes, so tasks and so on, with the instruction then from the resource manager, basically for the scheduling, what to do with the application. And in the end, you have this data nodes here on the lowest level, which was very important, if you remember, for Apache Hadoop, to basically put the task where the data is, and not what we do maybe, for instance, in HPC a lot. We put a lot of things to the HPC services or centers, and then compute it there, and then take the data again away. Here we talk about a little bit a different scenario. If you have the Apache Hadoop interface, you rather accumulate data maybe in different branches of your organization, maybe even geographically dispersed, but then you come back to this and combine it with this MapReduce, over all this organization boundaries, with the idea of, divide and conquer that we discussed already in one of the lectures. So you see also, because we're at the end of the course, we're using a lot of these lectures that we had before, we're starting to repeat ourselves, because that is also, of course, then the point of OpenStack. Because essentially you have again and again similar requirements, even if you do Apache Spark, Apache Hadoop. They're very similar in the upsetting, of, for instance, divide and conquer, map reduce tasks. You remember then, of course, we should have probably a Nova service on top of some hardware that has lots of memory, right? Because you remember, Spark was living a lot from good memory compared to Apache Hadoop. But if you don't have much memory, then maybe also Hadoop is good enough for you to do this infrastructure as we described here. Now, as I said in the beginning of the lecture, OpenStack is a tool that really needs a course from Monday morning to Friday evening. So really a long, let's say, training course, maybe from industry or so. And as a university course, it would be, let's say, also very feasible to have, especially if you want to go into some details of usage, some examples, some assignments. But we have to always pick carefully what we put in our course to give you a comprehensive overview what cloud computing is. But I think OpenStack now summarizes it nicely, also that things you can do yourself in your own organization. And remember, don't start from scratch. There's lots of things already implemented. The only question is how you combine that. And here's a nice video for this, a little bit again to summarize that up. And with this, I'm also stopping now the last, if you want, real content lecture. We will continue with a final lecture 16, which is also a short lecture where we then summarize the course a little bit and see what you have learned and also see how that works with job descriptions if we can map the topics. So talk to you then.